In financial domain, we can apply data science and AI for solving multiple problems. So for example, if we are a company which is giving credit cards to the customers, right? Then we can use historical credit card data of people who took the credit card and then paid all the payments on time, and people who took the credit card and didn't pay payments on time, right? And then use that data to train our machine learning model for predicting future credit card defaults for any new credit card application. Similarly, all the fintech companies which are instantly approving the loan as soon as you submit your loan application, they are using data science and AI for predicting the chance of loan default, and then basically according to that, they are taking decision whether to give loan to this particular person or not. Then when you invest in multiple products, like for example in mutual funds or in stock market, then that investment can also be made personalized based on your credit history, or based on your financial history, what amount of money you have, where you want to invest it, your risk appetite, and then based on that you can create a recommendation model which would recommend you portfolio across different sectors. So basically data science has application across multiple problem statements in finance, and what we would do today is we would build an engine or a machine learning model which would predict whether to give loan to this particular person or not. Let's get started. So at the beginning, we are importing all the libraries which we need. So we are importing numpy, pandas, and then from scikit-learn, which are functions and models which we need, we are importing them. And along with that, we are also importing the visualization libraries. Okay. So in terms of the data that we have, it's a historical data related to the loan applications. So this is a quick snapshot of the data. So we have information about loan ID, then the gender of the person who has applied for loan, whether the person is married or not. Then we also have information about number of dependents on that particular person, educational background, whether the person is self-employed or not. Then we also have information about the income, because whenever we want to give loan to anyone, right, it is very important to know what kind of income that person has. Then we also have co-applicant income. Then we have information about the loan amount which is applied, the information about loan amount term, what's the term for which that particular loan has been applied. Then information about whether we have credit history of that particular person or not, and that person is coming from urban area, rural area, or a semi-urban area. So the property area information also we have. And then at the end, we have a loan status column, which is yes or no. So whether the loan was sanctioned to this person or not. So this is the information we have related to the loan applications. And in total, we have 614 loan applications for which we have the data. Now what we would do is we would try to build a machine learning model which can automatically predict based on the data whether this loan application should be sanctioned or rejected. Okay. So the initial step that we would do is we would explore the data. We'll try to understand the data before doing any machine learning modeling. So here what we are doing is data frame df.info. So that would give us information about the data frame. So these are all the columns which we have. And if you see, we are also getting the number of non-null values. So in loan ID, we have 614 non-null values. So basically we don't have any missing values. In gender, we have 601 non-null values. So there seems to be some missing values in gender column. And similarly in dependents also, we have few missing values because the non-null values are just 599. So these initial columns, if you check their data types, it is object. So basically these are categorical columns. We have information in the form of predefined categories. Then we have applicant income column where we have information in the form of integer. Then we also have information regarding co-applicant income, loan amount term. So that information we are getting in the form of float. And then at the end, we are also getting information regarding the loan status, whether the loan was approved or not. Then using describe command in pandas, you can check the information for every column. Specifically here, we are checking information for all the numerical columns. So what we are doing is data frame name dot describe. So that would give us information about all numerical columns in that particular data frame. So basically with respect to applicant income, the average value which we have is 5403. and the minimum value is 150 and it is going all the way up to 81,000. Then co-applicant income, the average value which we have is 1621 and the minimum value is 0 and it is going all the way up to 41,667. So this is account basically the information that we are getting in terms of the loan amount term. The term for the loan, the average value is 342 and it is starting right from 12 months and going all the way up to 480 months. So basically 40 years. So this is how we have information regarding various columns. And now let's check what's the percentage of missing values which we have in every column. So what we are doing here is data frame name dot is na, and then we are summing up the missing values that we are getting, multiplying it with 100 and then dividing by the total number of rows we have in df. So this would give us percentage of missing values in every column. So over here, if you see in loan ID, we don't have any missing values. Then in gender column, we have around 2% missing values. Similarly for dependents column, we also have 2% missing values. Then whether person is self-employed or not, in that column, we have 5% missing values. And the highest number of missing values are in credit history, which is 8%. So basically we have few columns where we have missing values. So we'd have to handle those missing values before we go ahead and build any machine learning model. So in terms of the gender column, most of the data in this particular column is following under male gender. And then we also have few female applicants as well. Okay. So this is what we have. So when you have data in the form of categorical columns, the most used methodology for missing value imputation is basically imputing the value using mode value. So mode value is the most occurring value in that particular column. So in this particular column, the most occurring value is male. So what we are going to do is wherever we have missing value in column gender, we are going to impute that value using value male. So what we are doing is df gender is equal to df gender dot fill na, and then we are passing this particular value which we are getting. So basically mode value in column gender, which is basically male. So we are imputing the missing values in column gender using value male. Then the next column where we have missing value, it's column married. So if you see here, around 200 plus people we have which are not married and around 400 people are married. Now in this case, if you check again, the mode value for this categorical column would be the most occurring value, which is yes in this case. So what we are doing is we are imputing the value in column married using mode value, using a fill na method in pandas. So basically these are the simple missing value imputation strategies which we are using. But if you are working on a data where really data is missing for more than 10% of the values, right? And you are able to impute that data based on some other column, you can always think of those strategies as well. But if there is no such relation with other columns for imputing the missing values, then you can always go ahead with the simpler methods. Basically mode imputation for categorical columns and median imputation for numerical columns. So the next column that we have is dependents. So in terms of the number of dependents, around 350 loan applicants have 0 dependents, around 100 loan applicants have 1 dependent. Then we have few people with 2 dependents and more than 50 people with 3 plus dependents as well. So this is the data we have with respect to number of dependents. So if you check the number of dependents here, so for 0, 345, for 1, 102. So the most number of occurring value in this particular column is 0. So if you check the mode of column dependents, it is basically 0. So what we are going to do now is column dependents, we are going to impute the value, which is the mode value. So wherever we have missing value in column dependents, we are going to impute that with value 0. So again, we are using the mode imputation over here because this is a categorical column. Then the next column that we have is self-employed column. So in self-employed, around 500 people are not self-employed and around 100 people are self-employed. So in this, if you check the mode value that we are getting, it's no. This is the most occurring value in this column. So we are going to impute the missing values in column self-employed using the mode value. So again, we are doing the missing value imputation over here. So if you see here, now we are left with the 3 columns which are having missing values: loan amount term, and credit history. So these 3 columns are numerical columns, and we are going to do the imputation for them using median value. So for numerical columns, you can either use mean value or median value for the imputation, but median value is impacted by the outliers. So if there are any outliers in that particular numerical column, your mean value would get impacted. That's why it is better to use median value for the imputation. So in terms of the loan amount, the median value that we are getting is 128. So we are going to impute that. So df loan amount would be equal to df loan amount fill NA, and in that we are passing the median value which would be imputed in this particular column. Then similarly for loan amount term, we are going to use the median value which is 360 for imputing. So this median value would get imputed in this particular column using again the fill NA method. And similarly for credit history, if we check credit history, in this case basically we have data in the form of category. So it is 0 and 1.0. So the mode value in this case is 1.0 because this is the most occurring value in credit history column. So we are going to impute that using this mode value. So we are using the fill NA method over here and passing it the mode value for column credit history, and that would basically impute the missing values. So if you check missing values now, in all the columns we have 0 missing values. So we have successfully completed the missing value imputation step, and now we can go ahead and build our machine learning model. Okay, so this is the data we have. Now if you see here, gender information is in the form of male or female. Then in married column we have yes or no value. Then in education column we have whether person is graduate or not graduate. So when we build machine learning models, most of your machine learning models would understand the data in the form of numbers. So let's convert the data in the form of numbers so that models can understand that data. So over here, the loan status is in the form of no and yes value. So what we are doing is we are going to replace this no value with 0 and yes value. So basically flag y with 1. Then in gender, we are replacing male with 0 and female with 1. And similarly, we are doing this operations in education, married and self-employed column as well. So if you see in these columns, we have only 2 categories. So we can directly replace them with 0 and 1. If we had more than 2 categories, then we can create additional features basically using the dummies function, pandas dummies function. But here we have only 2 categories, so we don't have to create additional features. We can just replace the categories with 0 and 1. And loan status is basically the value which we are going to predict. So we are encoding that as well into a numerical format. So after we do this step, this is what we would have. So we would have information now in the form of numbers. Only thing now that is remaining is dependents that we have, which can be 0, 1, 2 and 3 plus. So 3 plus is basically a category. And we also have property area, which can be urban, rural or semi-urban. So even this is remaining still in the form of categories. But as there are more than 2 categories in these 2 columns, we would create dummy features for them instead of just replacing the values. So basically what I'm doing now is I'm creating a function here for training and testing data split and feature creation. So what this function would do is it would split our data into training and testing data set. Because whenever you build any machine learning model, it is very important to separate your training data and test data, because then you can train your machine learning model on training data and then evaluate it on your test data. So that's what we are going to do over here. So I'm calling this function train, test, split and features over here and passing it our data frame df. So this is the function, basically definition of that particular function. So what is happening in this function is we are creating variable y in which we are storing loan status. This is the column for which we want to build a predictive model. Then in X, we are storing all the features, and obviously in that we are dropping loan status and loan ID, because loan status is the value which we want to predict. So obviously we cannot use it as a feature, and loan ID is just the unique number representing the ID of that loan application. So that is also not going to help us in building better model. So we are dropping that as well. Then as I mentioned above, for columns, property area and dependents, these columns have more than 2 categories. These features have more than 2 categories. So we are going to create dummy features for them using pandas get dummies function. So basically this would create a column each for every category in that column. And that column value would be 0 and 1 based on whether that category is present or not. So this is what we are doing over here. Then for train test split, we are using the train test split function from scikit-learn, passing our feature data, our y value, and we are keeping test sites as 0.20. So basically we are keeping 20% data for testing the model and 80% data for training the model. And after that, we are just printing the data that we have, okay, and then saving all the features into variable features and returning everything over here using a return statement. So if you check now, this is how our training data is looking like. We have various columns and every column is now in the form of numbers that we wanted. So if you see here for dependents 0, dependents 1, dependents 2 and dependents 3 plus 4 columns were created. So basically a column for every category was created using pandas get dummies function. And every column would either have value 1 or 0 based on whether the dependents are 0 or not. Similarly, when none of the dependents are equal to 1, this column value would be equal to 1, otherwise it would be equal to 0. So this is how now we have created our feature matrix for building a machine learning model. Now next step that we are going to do is we are going to actually build the machine learning model that we want. So what we are doing over here is we are creating a function fit and evaluate model and then passing it our training data frame, testing data frame along with corresponding labels. Now let's see what is happening in fit and evaluate model function. So this is the function basically which we have. So in this particular case, I'm using a random forest classifier. So you can use any kind of model. You can use XGBoost, neural network, support vector machine, or even logistic regression. But whenever you build any model, make sure that if there is no such requirement to start with complex model like neural network, or if there is no such requirement to start with simple model like logistic regression, you use some form of a non-linear model. So usually I recommend people to start with random forest or XGBoost model because these models are really good in capturing linear as well as non-linear relationship between input and output, and these models also give really good results on most of the data sets. So you can directly start with them. One of the mistake that I have seen many people who are learning data science and machine learning first time they do is whenever they get regression problem, they start with linear regression. And whenever they get any classification problem, they start with logistic regression. But don't do that because those models can capture only linear pattern. But in this case, we want to capture linear as well as non-linear pattern because we don't know what kind of pattern is there. So it is better to go ahead with non-linear models. So what we are doing is we are initiating a random forest classifier. We are keeping the maximum depth of the trees equal to 5. So this would create trees which would be having maximum depth 5. Then we are keeping the min sample split 0.01. So basically this is the threshold for splitting the tree. So there should be at least 1% samples available for splitting or creating any new split in the tree. So this is that threshold, mean sample split. Then we are passing another threshold, max features equal to 0.8. So it means that whenever there is any tree created at any node, only 80% of the features would be used for evaluating the split. So the max features equal to 0.8 basically represents that we are going to use only 80% features max for creating any split or evaluating any split at any particular node within a tree. And then we are keeping max samples equal to 0.8. So this is related to the bagging concept within random forest. So max samples 0.8 means for individually building any tree. So if you know how random forest works, we are going to build multiple trees parallelly. So every tree would be using only 80% of the data in terms of the total training data that we have. So within that also we are going to use only 80% data. So this is called as basically bagging concept within random forest, and it helps in avoiding overfitting. So we are keeping max samples as 0.8. Then we are initiated the model over here, and then we are applying the fit function randomforest.fit, passing it our training features along with the labels. And then we are predicting. So after the model is trained, we are applying it on the test data. And that would give us basically the predicted labels. After that, we are creating a confusion matrix. by passing it our test labels and the labels which we have predicted from the trained model. Then we are calculating the accuracy score, and after that we are also basically printing the classification report, which would give us precision recall and all other values which we want for evaluating any machine learning model. So if you see here, this is the confusion matrix which we are getting. So how to read the confusion matrix? So basically first row is for class 0 and second row is for class 1, and this means that we are able to predict 14 samples correctly within class 0 and 19 samples we are predicting them as class 1, and when it goes to class 1 we are able to predict 87 samples out of the 90 samples correctly. And if you remember, in terms of which is class 0 and class 1, we did the encoding over here. So loan status yes is basically our class 1, and loan status no, that is n, is our class 0. So wherever the loan is approved, the class is 1, and wherever the loan is not approved, the class is 0. Now if you see here, for class 0 we are getting precision of 0.82 and recall of 0.42, and overall F1 score that we are getting is 0.56, and for class 1 overall F1 score that we are getting is 0.89, and the accuracy of this random forest model is 82%. So basically we have built a decent model without doing lot of work with respect to hyperparameter tuning or anything else. So on top of that, now what you can do is, we use these fixed parameters, right? So you can try different values of these parameters and do hyperparameter tuning using cross validation. That might help you to find better parameters which would improve the results slightly. Right. Then what we are doing is we are storing the important features that we are getting from a model. So if you do model.feature importances, that would give you the important features which are calculated based on how the features are used across the trees. That would give you importance of every feature. Okay. And we are storing it in a data frame importances, and then we are sorting the feature values over here based on the importance score. So this would basically give us all the feature importances. So every feature and its corresponding importance. This helps in better interpreting the results that you are getting. So suppose you built your machine learning model and you are presenting it to stakeholders in the industry, right? They would ask you based on 10, 12 or 15, whatever number of features which you had, which features were really important in building that model. So you would be able to answer those questions based on these feature importances. So if you see, now what we are doing is we are plotting a horizontal bar plot using matplotlib and passing it our features and corresponding importance scores, and that would give us the feature importance plot. So if you see this plot, the most important feature is credit history, whether we have a credit history or not, then the income of an applicant, then what amount of loan the person is applying for, what is the income of co-applicant, then what is the term for which the loan is applied. So these are important features. So the way in which you have to read this graph is these numbers or this magnitude is telling relative importance of that feature as compared to other features within that feature set. So these 5 I would say are really top features within this model. So if you try to drop feature credit history and build this model again, you would see that your overall results are not as good as the results you have right now, because these features are really important. Now based on this feature importance graph, you would be able to have good conversations with your stakeholders. And when you think of a data science interview, right, on this project you might get questions around how you explored the data, how you did the missing value imputation, then which kind of model you built, how you decided the hyperparameters. Then you might get questions around what is max depth in this particular case, what would happen if you keep max depth 20. So you should be able to answer those kind of questions. Then what would happen if you keep max features as 1 all the time, you are not doing any backing on the features, what would be the disadvantage in that case? So those kind of questions you would get on these projects, because interviewer would try to understand how you're understanding that particular project. Are you having complete idea end to end, or you have just built that project using what you know? Then you will also get questions around important features, which features are important, then how those important features were identified, because this would help you in better understanding of the overall project. Then when you get any predictions from the machine learning model, you can get predictions in the form of labels as well as probability, because ideally the predictions that you are getting from machine learning naturally, they are in the form of probability. So what we are doing over here is we are using model.predictproba. So predictproba is the function that you can use when you want predictions in the form of probability, and pass it your test feature matrix, and then in next line we are predicting the corresponding labels using the predict function. So if you see here, right, every prediction you have two columns. So the first column is basically probability for class 0, and second column is probability for class 1. So here if you see here, the probability for class 0 is 0.19, probability for class 1 is 0.805. So in this case, the predicted class by machine learning model for this loan application is class 1. That's why you see 1 over here. So basically, using machine learning models, you can get predictions at the probability level as well. Now, if you want to improve your results further, what you can do is you can also play with these probabilities. So based on the probability scores, you can decide what sort of threshold you want to keep, because it is not must that you have to keep your classification threshold at 0.5. You can use various other thresholds as well. So you might be maybe more concerned about applications which are high risk applications. You don't want to maybe miss them. Then accordingly you can play with your probability threshold and then see what kind of predicted label you get. So you can always decide what kind of threshold you want to use for predicting class 0 or class 1. And that decision you can also take based on precision recall analysis or precision recall curve, and see for various kind of thresholds what kind of precision recall value you are getting across the classes, and then make your decision. So I hope you are clear now in terms of like how you can use machine learning and data science in financial domain, because now we have a model which can tell instantly whether this particular loan should be approved or rejected. Now if you can imagine, this kind of a model has clear application in fintech domain, where people are submitting their loan applications online through mobile app, and then instantly you would get approval or rejection based on the kind of data you have. So try to build now more models into the financial industry, because there is a huge number of data sets which are available on websites like Kaggle, and you can try to build your own machine learning models, and those would help you in gaining confidence. Thanks for watching the video, and I will see you in the next one. Bye bye.